So yesterday we started discussing about exception scenarios and what happens in exceptions cases and how Java handles the exceptions, how it treats the exceptions, how it treats the errors. So if we recap quickly, there are two types of problems. One is exceptions and another one is errors. Errors are something which we cannot handle inside the program. What you need to do, you need to explicitly go back and correct the program. You need to go back and restart the program. You need to go back and fix the program. Whatever the logic that you are written inside is causing the problem. One of the problem that we observed is stack overflow error because of the cyclic dependency that we created, right? Second one is exceptions. Exceptions which can be handled. Exceptions which can be handled. So all exception classes built in Java exception classes. Whenever I say built in, there are some classes already available by Java. Okay, all built-in exception classes are all classes. There is no interface. Okay, all exceptions are subclass of java.lang.exception. Okay, you do. If I don't know, I don't remember whether I explained to you guys or not. In order to use any classes inside this package, generally what you do, like if you want to import a scanner, what you will do, java.util dot, you will get, when you try to write a scanner built-in class, you will get an immediate error, import that class, right? But java.lang package, whatever the classes, like there may be hundreds of classes inside java.lang package, you don't need to explicitly import them. You don't need to explicitly write on the import java.lang some class, because they by default available for you. When you write Java classes, by default those classes will be available for you to access. Okay, so all the exceptions classes are subclasses of java.lang.exception. All the subclasses, in the sense, these are all subclasses, this section, all the subclasses of exception class not found exception, runtime exceptions, all the above. Okay, in all the classes we will see only constructors. All the classes we will see corresponding constructor classes. We don't see any methods, but all the methods that we are using towards constructor classes are in throwable class. Throwable class is the superclass of your exceptions block. Exception classes, throwable class is superclass. So all the methods that you use here, and here are available here in this class. You see, parent-child relationship, don't forget and don't get confused those concepts. Okay, that's always continuous going forward. Okay, we don't have in all exception class there will be only constructors. We don't have any methods. All exceptions subclasses are using superclass throwable methods, like I mentioned here, get message, print stack trace, all kind of errors. Okay, next concept is, like, we handle the exceptions using the certain keywords that has been provided by Java: try, catch, finally, throw, throws, right? Try block is used to place the statements need to be monitored in case of abnormal behavior. So what kind of statements goes there inside try block? The statements that you expect something will go wrong. The logic that you return in that statements, something will go wrong. And catch is something, if something go wrong in the try block, catch is the one who can get to know what exactly went wrong. So you need to be very carefully define the catch block. You can write as many catch blocks as you want, but they should be immediately next to try block. And if you write more than one catch block, the rule and definition is, first you need to mention the subclass, then only you can increase to the superclass. So all the subclasses and then into the superclass, right? So in that sequence, when I'm talking about in that sequence, you wrote the try block. In this sequence diagram, first you need to, in the catch block, you may need to write if you expect index array out of bound exception, then you need to write index out of bound exception, then you need to write runtime exception. So that is the sequence you need to go. Okay. And can we write try without catch? Yes, we can write, but you need to have finally. Try finally is allowed, right? So let's see. Catch block is used to catch the exceptions raised by the try block. Catch should be followed by try. Other statements are not allowed between the try and catch. For one try, we can write more than one catch block. In case of more than one catch block, order of exceptions must be subclass to superclass. In case of more than one catch block, order of exceptions must be subclass to superclass. That's what I explained, right? So what is finally block? Finally block is used to for the statements which need to be executed irrespective of the exceptions occurred in the try block. Okay, so what exactly it means is, you have try block, catch block, and then finally, right? Sorry, finally. Okay, can you guys go on mute? Okay, try, catch, and you return, like, let's say we have 10 statements here. Okay, and you got exception at 5th line. What happens? From 5th line to 10th line, the logic won't be executed. From here, the logic will be jumped into catch block, right? Agreed. What let's say in this logic, what the logic you have is, let's say in the first 4 lines you connected to the database. Basically you may not aware, basically there is a rule is database is outside JVM, right? So simple terms, like when you connect to the database, it will connection establishes, okay, and then you do some operations with that connection. Once you're done with that operation, you need to close that connection. That is the rules that has been defined. Otherwise what happens, connections keep on opening and database will go down if it doesn't close the connections properly. So let's say you return the logic here, open the connection, do the operations, close the connection. Okay, so open the connection, do operations, close the connections. This is the logic you written here. So open the connection, while doing your logic, the database some problem occurred and immediately it jumped into catch block. So you didn't close the connection. So if it happens repeatedly, what happens? The connections to the database will never be closed, right? When that happened, what happens? Your program will stop working. Like say database have maximum 1000 connections. Then if it happens when 1000 times, and when it comes with 1001 time, then you don't get the connection because all the connections has been established, and while doing this operation failed and never closed. This logic never executed. That is the reason all those kind of, no matter what happens here, if you want to do certain things, if you want to happen certain things must, right, those statements should go here in finally block. So instead of writing here the finally block, close block, then you can move it into finally block. Those logic, move it into finally block. Clear? So finally block is used for the statements which need to be executed irrespective of the exceptions occurred in try block. Only one finally is allowed for entire try block. More than one catch blocks are allowed, right? But in terms of finally, only one block is allowed. And when you have statements like system.exit in the try block, then finally may not be executed. System.exit is like, shut down the program. While running the program, if you write this line, you are saying shut down the program. Then it never reaches the finally as well. This is one of the exception scenario when finally cannot be executed. Okay. Then another scenario is when the running thread interrupted while executing the try catch statements by killing the thread, then finally won't be executed. When try block goes to infinite loop, then finally won't be executed. So except these three scenarios, all the times finally will be executed. A lot of in interviews, right? When you go to face or when somebody want to test you in core Java skills, this is one of the questions they will ask. One question is, when is the finally block doesn't execute? When you have system.exit 0, or when the running thread interrupted while executing the try and catch statements by killing the thread, then finally won't be executed. When try block goes to infinite loop, then finally won't be executed. These are the three scenarios. These are the three important scenarios. The try block won't be executed. Apart from these three scenarios, finally will be executed all the times. Only one finally allowed for each try block. Okay, so these are the allowed scenarios. So try catch, try finally, or try catch catch, try catch finally. These are the different scenarios, different code snippets that has been allowed. Okay. So let's, what we can do, we can write a simple program and then we can convert into method level exceptions. Create the class. Try catch finally scenario. Okay, I'll have a static method. Because I can easily call, no need to create an object, right? And I'll have one more static method. Okay. And what I will do is, here I'll introduce a equal to 10 into b equal to 5, okay, for example. And then I pass these values to method 2, 10 comma 5. Okay. And method 2, what it is, inside method 2, and then it calls method 3. Int same values, okay, int a, int b. Here you can take int x, int y. Okay, I believe you don't have any doubts here, right, up to here. Okay. Okay, so what we're going to do here is I'm going to take int c equal to 0, and now I'm going to write try. So it's already added. Try catch thematic exception. Here what I'll do is like c equal to a by b. Sorry, x by y. Okay, so here I'll say arithmetic exception occurred. Okay, and then I'll say finally I execute all the time. Okay, so I'll call method 1 here. Regular logic, right? No one yesterday whatever we did, same thing, but we now we configured multiple methods to see different scenarios. Okay. Okay, inside method 2 first. Okay, let's say here I'll say so inside method 1, inside method 2, inside method 3, I execute all the time. Okay, see result you haven't displayed, right? That is the reason you didn't see. So basically what you will do here, see. So C value is 2. Okay, now what if I change it to B value 0 here? What happens? Inside method 2, inside method 2. Oh, okay, sorry. Here I need to pass what? AB, right? Manually. Now let's run the program. Now you will get inside method 1, method 2, method 3, arithmetic exception occurred. I execute all the time. Okay. So while doing this operation, something happened, but it didn't execute this statement, but this statement must be executed all the time, right? Irrespective of the exceptions occurred or not. Nice. Let me try to one more exception I'll create. What exception I'll do is here I will say int int arr int array equal to new int of. Okay, now what I do here is I'll try to keep, okay, this is initialization, right? So what I'm going to do is I'll try to here add a index 3. On index 3 I created only an array of index 1, only one index, but I'm going to add some value to an index of 3, which will give an error again, right? Let's see. Now see, I execute all the time and then you got an exception. Why? Because you are not handling this exception. This is array index out of bound exception, but you are handling only arithmetic exception. What you can do, you can write another block saying array index out of bound exception. You got my point? Next one. Let me introduce. I'll create, what I create is like I'll create this class object. Okay, another exception. Try catch finally scenario try equal to new try catch finally scenario. Okay, this is a try catch finally try. Okay, this is the valid object. Okay, from here let's say you have a method called public void method 4. Inside method 4, right? So if I run this program and if I try to do this here, tcf dot method 4, it runs perfectly fine and it displays method 4 as well, right? Method 4 inside method 4 works fine. But what if without creating this object, with the reference variable I try to access? Equal to null, I'll say. Okay, let me run. You get something error, some other exception. What is that exception? Null pointer exception. Without creating an object, you try to access that method's object. You try to access method in that object. What happens? It gives the null pointer exception. So what do you need to do? You need to handle the null pointer exception as well. You getting my point now? So each scenario will fall into different kind of exceptions. Okay. So this is how we can use. If you observe all the time this finally is executing, right? That is fine. And you can try out by writing system.exit here whether finally is executing or not, or else here like create a circular dependency and see finally is going to execute or not. All the three scenarios you can understand. There is no time, we don't have a time to do all the stuff. Okay, so now it's perfectly fine. This program is working fine and you handled very well and everything is fine. But the only interesting thing is, certain scenarios. See, method 3, who is providing these inputs? X and Y is provided by method 1, right? Method 1 knows very well about what kind of inputs he is providing than method 3, right? Method 1 knows what kind of inputs he is providing than method 3. Then it would be always better to delegate handling the exceptions to method 1 than handling at method 3, because what I'm trying to see, right? You see, the c equal to x by y, there are higher chances this failure happens because of inputs that has been provided by method 1. So sometimes in your code, day-to-day code, forces you to leave the exception handling to the caller than called function. Okay, in that scenarios, what you need to do is you need to go for throws. Throws is a method level exception. Statements inside method may throw some exceptions. If you want to handle them, you can do that by surrounding those statements with try catch block, one option. Or if you don't want to handle the exceptions inside that method, then throw that exception to the method whoever calling. Okay, so instead of handling here with arithmetic exception, let this exception will be handled by this guy. Okay, what they are saying is, let's see, simple throws arithmetic exception, don't handle it here. Okay, and then he is the caller, right? And you first, who is calling this guy? Method 2. So does method 2 knows anything about these inputs A and B? No, he also called by someone, so he also need to throw. Try to understand. Yeah, right. Arithmetic exception. So what happens is, now see, if something goes wrong in this block, if it is array index out of bound exception, this array index out of bound is being started in this program itself, so we are handling with the catch block. And null pointer exception also happening in this block, started happening in this block. Nobody is passed these values, so we can handle here. But this operation, this logic, as based on the inputs provided by x by y, whoever providing, you just need to throw it. So method 3 just throws to method 2. What method 2 will do? Hey, I also called by someone. Yeah, I'm not the responsible. I'll just call the caller. So here you must handle that error. Like, how do you handle it? Try catch, what do you call it? Arithmetic exception. I just copied, right? Let me try. Yeah. Do you guys understand now? So this guy, simply, if that exception happens because of this line, you just leave it to the caller, because caller is the one who providing inputs. He also, method 2 also doesn't also not introduce these values. He just called by someone else with those values, so you just leave it to him. He knows very well about what are the values he is passing, so you need to go back and correct it. Let's see what happens now. Same thing, nothing will change, same thing should happen. Null pointer exception occurred because that is the statement. So now see, right, we are introducing here 3 different exceptions, right? This is null pointer exception introduces, this is array index out of bound, this is arithmetic exception. So if something happened here, like you said, like I said, you remember, it never execute any of these statements, right? That is the reason it didn't show the arithmetic exception. So null pointer exception happened and it came out from this block. So let's say I want to introduce arithmetic exception. You need to move arithmetic logic into top. So arithmetic exception occurred. Where is that logic? Here. So what happened? Now what happened in this case? It's tried to do this operation and divided by 0 is resulted into arithmetic exception. Immediately try block looks for a catch. Do you have arithmetic exception handling capabilities? Do you have arithmetic exception handling capabilities? No. Okay. Is it throwing? Okay, this guy is throwing some method. Okay, I'll go to the caller of the method. Okay, method 2 is calling me. Hey, method 2, are you handling this? No, I am. He is also throwing it. Okay, let me go to the caller of method 2. Okay, method 2 is called by method 1. Oh, this guy is handling. Okay, is there any arithmetic exception? Yes, we have an arithmetic exception. Let's throw it. Okay, so throw is a keyword used to specify the method level exceptions. Statements inside the method may throw some exceptions. If you want to handle them, you can do it by that surrounding those statements with the try catch block. If you don't want to handle them, the exceptions inside the method, then throw them calling the method using the throws at method level. Clear? That's it, throws. So what else left? So let's say, can I throw only one exception? You can throw as many exceptions as you want. Let's say this culprit also came from here. Okay, let's I'll adjust the program to make method 1 as the culprit. Okay. Now I'll say comma some index, okay, 3 2 or something like that. Okay, so here I need to do correct the program which will accept int of an array arr comma int index. Okay, same thing, we need to pass these two values here, and here same thing we need to do whatever we're doing here, right? But a small correction we need to do here, index. Okay, so what we're doing, we are passing an initialized array of size 1 and we are saying add some value on index 2. So something wrong. So this is the guy is himself passing the some wrong data, and we just carrying these two guys carrying the data and giving it to him here. And here we are saying like on this index add this value. So the size of the array is 1, but he is asking us to insert on 2, index 2, right? That is wrong. So who introduced this problem? This guy, method 1, right? So now if you run this program, let's move this guy up to introduce this error, right? Array index out of bound exception. But you are handling here, he need not to handle because he is not the responsible who introduced, right? Whoever responsible, they need to handle it. So what you can do, you can simply comma separated array index out of bound exception, and then here you need to do again same thing. He is not the one who introduced array index out of bound exception. Nice. So all you need to do here is introduce array index out of bound exception and do some exception, say something, okay, do something, blah blah blah. Now run the program. This call got called. Now this was index happened, it looks for null pointer exception, it's not null pointer exception, it's array index out of bound exception. This guy is not handling, so he goes and looks. So he's throwing it, yes he is throwing it, and then he looks, okay this guy is throwing, yes this guy is throwing it, okay good. So otherwise what happens, right? Let's see if I don't throw this guy, you can see the difference. Sorry, how come this ended? If I don't throw it, if I don't do it, you will get array index bound of expression. Okay, so that is one thing. And next concept, I hope you guys understand, right? Throws is something like which you don't want to do it, you want to give it that handling of mechanism, exception handling mechanism to the caller, whoever called with the improper data. Okay, so another one is, last one is, we remember try, catch, finally, throw, throws. So we understand finally, catch, try, catch, finally, throws. Now last one is throw and throws, that is throws. Okay, use it to throw the exceptions in your own. JVM handles the built-in exceptions. JVM cannot handle the application level exceptions or user defined exceptions. So as of now, we are handling the exceptions that has been defined by JVM. JVM provided us a built-in exceptions like hundreds or 200s of exceptions, different exceptions. If something happens in those, if your statements failed and the failure, if built-in exception is able to identify, then corresponding built-in exception will be thrown. But what if the scenarios like, let's say, okay, bank scenario, right? You try to take you try to transfer amount. Okay, you try to transfer an amount and you entered some negative number. Instead of sending transfer 100, you said like minus 100. Is minus 100 is wrong in general scenario? See, A by B, if you enter B 0, it is wrong universally, right? So that is the reason Java handled it with arithmetic exception. But in banking sector, while doing transfer, entering minus 100 value is negative number for transfer amount is invalid, not universally. It's a bank sector defined exception, right? Or else, let's say you are transferring, you are adding an account, your friend's account. Before transferring, you try to enter, instead of numbers, you try to enter ABCD. Here, ABCD is not technically wrong, but the concept of banking sector, when somebody asks to enter the routing number, you must enter the proper code. You must enter when somebody asks account number, you must enter the proper 12 digit account number. Otherwise, an application cannot be processed. So in that case, banking sector has its own exceptions, right? And like that, everybody has their own set of exceptions. And Java cannot answer all of them, right? So what comes into my picture, like why Java thinks like, why can't I allow the coders, the developers to write their own exceptions? In those lines, what they did is they allowed, okay, if you want to write your own exceptions, just follow these standards. You are going to build your own exception, and you can use your own exception in case of particular scenarios where you want to handle your own exception, your own exception scenarios. Okay, so one second. Write your own exception class by extending java.lang.exception. So how do you write, right? So these are the definition. Write your own exception class by extending the java.lang.exception or java.lang.end runtime exception. First thing, if you want to write your own exception, then write one or more constructors based on your requirement and override toString method, and if requires override toString equals a dashcode method. So these are the 4 definitions that has been defined for user defined exceptions, right? So let's go ahead and try to write our own user defined exception. Okay, what I will do, I will write a program with the card. Let's say I will consider, like, if somebody enters 16 digits from the console, then I will consider it as valid credit card. Otherwise, I will say that it's an invalid credit card number. Please enter a valid credit card number. This is how I'm going to treat my exception now. So my exception is what? If somebody doesn't enter 16 digits, then I will consider it as it's a wrong credit card number. I won't process his order. Okay, let's see how we can do it. I'm going to write an exception class called card invalid exception. Okay, what you need to do first and foremost thing, you need to extend, see, write your own exception class by extending java.lang.exception or java.lang.runtime exception. I'm going to extend extends runtime exception. Okay, then next statement what they are saying, write one or more constructors based on your requirement. So for now what I will do, called, I'll just write default constructor. Okay, I hope you guys didn't forget about the constructors. And then override toString method. Let's say, how do you override? Where is the toString method to override? It is in object class. Object class will be automatically extends, right? So you need to override. How do you need to override? You need to take as is, right? Signature string to string. If number not equal to null, yeah, I'll take like user entered some number, right? So I'll take it as a string. Okay, if number is not equal to null, or else you don't need to do anything. Okay, blah blah blah, simple. You need to write here, we'll get into that structure later. Return invalid card number. Card number must be of size 16. This is what this is the you write your own exception now, right? I'll show you how to throw it. You need to see the real example, right? So let's go back and write another class called user defined exception demo. This is the main class I'm going to. What I'm going to do here, I'm going to write some logic where I'm going to have a static method, static void method 1. I'm assuming somebody is going to give the number, whoever caller. Okay, and here let's say now let's write a try system.out.println, enter your card number. Okay, no magic, just everything is same, right? Whatever we do day to day. Scan equal to new scanner. So import this guy, new scanner of, you are saying from console system.in. Okay, string number. Now take it from the user, scan dot next. So I took the number. All I'm going to do is I'm going to pass it to method 1, that number, and I'll let method 1 to take care of processing, verifying all the validations, or validate we call it as. method validate. Okay, and here I'll say catch card invalid exception. This is the class I wrote right just now, card invalid exception. That is the exception that I am creating. C, whatever your object name, it's a reference variable, sys vout, and then C dot toString. Okay, so what you going to do here, in order to raise this exception, when the number is not 16 digit numbers, when the number is not 16 digits, then you call it as invalid, right? So if number dot length not equal to 16, then if number is equal to 16, what you will say is system dot out dot println, you will say, hey, we processed your, okay, so we accepted your card and will send your purchases on some so-called date, okay, 6/06/30, something like that, right? If the number is not equal to 16, you need to throw some exception saying you are entered invalid. That is how my definition. See, in order to process my credit card, in order to process my goods, I want to check some logic. For now, I am writing a simple logic called the invalid exception, and what I'm doing is all I'm going to check is if 16 digit or not, I'll accept it. If it is not 16 yet, I'll throw it. So how do you throw? Here is the one you're going to do. Throw new card invalid exception. You see what happened? So customer and user entered the number and you call the validate method. Validate method takes that number, it checks the length of the number. If the length is same, you said like everything went fine, done. If length is not same, using throw keyword, you are throwing new card invalid exception. When you throw this guy, okay, this constructor will get called. Okay, and then this is the guy who is handling, right? This is the guy. So it goes into here and then it tries to display ce.toString. Ce.toString is nothing but invalid card number. Card number must be of size 16. Can we try this program? Which program I need to run? This program or the user defined exception program? Wherever we have main method. Let's run this program. Enter your number 1 2 3 4 5 6 7 8 9 10 1 2 3 4 5 6. Hey, we accepted your card, we will send your purchases because the size is 16. Let me run this program again. Enter. Invalid card number must be of size 16. You see what I'm trying to say? You defined your own exception now. Actually this is, if you in Java world, 21212 is not an exception. It's a plain simple integer. But in your bank world, it is an invalid card number. Okay, so let me say you want to display back to the user saying like invalid card number, the card number that you entered is blah blah blah, that is something wrong and size must be 16. Here not displaying what he entered, right? Sometimes you want to convey to the user back, hey, the PIN number that you entered is wrong, this is the wrong number, kind of thing, right? How do you do that? So all you need to do is you define the number here and you write overloaded constructor string num and number equal to num will be assigned Okay, keyboard. Okay, and then here you can do is let both scenarios, right? If number not equal to null, then do something like this: return invalid card number of size 16, but you entered so this is what you're doing. So in this case, what you need to do, if you want to display here, instead of this guy, pass that number. When you pass that number, now let's see what happens. Enter. See, invalid card number must be, but you entered 322222. That is invalid. So you are able to capture it and return it back to the user. You see what I'm saying? Did you guys understand? Invalid card number. So now, even if I enter 16 letters with my current logic, with 16 letters, it works fine. Because I am not checking whether there are 16 letters are numbers or letters, alphabetics. So can you guys enhance this program that the number should be the whatever the user entered should be digits. Okay, so this is the assignment. User entered 16 characters should be digits, not alphabetics. Okay, and second thing, can you ask the user to, once he enter the card number, can you guys take date as well, expiry date? You need to check with the current date. Like if user enter, right, enter your card expiry date. If he enters like a 0608, then you need to say, hey, it's your card is expired in June 2008. I'm not going to process. If the card expired is like a 0620, you need to accept it. Okay, and CVV also, like user must enter 3-digit number, and if he doesn't enter the proper digit number, you need to throw like your 3-digit number is invalid. And if you want to so interested, if you feel this is so easy, you can try something like ask the kind of a card. Ask kind of a card. What kind of a card? If it is an American Express, then you expect like 4 digits. Okay, and ask them what kind of card it is. What kind of card also, like Visa or MasterCard or Discover, Amex. If somebody enters apart from these 4, throw him an error. You entered invalid accepted card. You accept only Visa and Master. If somebody tries to enter Discover, throw them an error. I don't accept Discover. Please enter Visa and Master. Can you guys enhance this program with all these things? Can you guys do it as an assignment? All you need to do is, now you entered your number, right? Take that number. Again, you need to start taking next what we ask, date function will be there in Java. Look around in date function and try to see the date and compare that with today date. Is it before today date or after today date? If it is after today date, accept it. If it is before today date, reject it. Same thing, 3 digits. If the Z enters CVV number properly or not. Okay, And then last one is kind of a card. Ask kind of a card, American Express, then accept 4-digit CVV, or if it is other cards 3-digit CVV, and what kind of a card again, whether it's a Visa or MasterCard. So by these things, you are kind of set up a program, and you kind of set up a program that where user must enter proper credit card number, right? So then only you process the goods, otherwise you will throw corresponding exception. Agreed with me? Like here, right, you now throw number only, right? So let's say write another block, like if number dot length is 16, but CVV is not 3 digits, then throw them an error by passing CVV. Your CVV is improper, you entered more than 3 characters, 3 digits, those kind of exceptions. Okay, take that assignment, please do an assignment, because this is every day. I can promise you can see these exceptions in your part of your code every day in your code. Okay, practice this example, take it as an assignment. And the last piece, like just concept in interview questions point of view I'm talking about. So there are two things: checked exceptions, unchecked exceptions, and caught exceptions, uncaught exceptions. Okay, remember, checked exceptions are all the exceptions are checked exceptions except runtime exceptions. Runtime exceptions and its subclass exceptions. So these blue ones are not, blue ones are unchecked exceptions. Unchecked exceptions. Checked exceptions are, apart from runtime exception and its subclass, all are checked exceptions. This piece. Okay, so examples are checked exceptions. Examples are IO exception, SQL exception, data access exception, class not found exception. So when you are trying to establish the connection, you will see an error. So checked exceptions must be surrounded by try-catch block or throws. Okay, so unchecked exceptions, just now we saw null pointer exception, array index out of order exceptions, illegal argument or arithmetic exception, illegal state exception. These are all unchecked exceptions. Okay, so they call, some people call it as a caught exception. Let me read it out. Checked exceptions and unchecked exceptions, right? Checked exceptions, these are the exceptions which are verified by compiler at compile time. By reading the name itself you can sense it, right? Checked exceptions are verified at compile time. All the subclasses of exception class except runtime exception and its subclass are called checked exceptions. Unchecked exceptions are which are verified at runtime. Runtime exception class and its subclasses are called unchecked exceptions. Okay. Otherwise, there are another way you can segregate your exceptions: caught exceptions, uncaught exceptions. Caught exceptions are, we must handle these exceptions, otherwise it will give an error, must be caught or declared to be thrown. Okay. Uncaught exceptions are, you don't need exceptions, or you like it which cannot be identified at compiler, cannot be identified, and it won't give an error, but must be caught or declared will be thrown. So what about user defined exceptions? User defined exceptions are unchecked exceptions and caught exceptions. Let me write those statements. User defined exceptions are unchecked exceptions and caught exceptions. So another segregate is caught exceptions. This is the concept. here checked exceptions, unchecked exceptions. That is how you, one way to segregate exceptions. Another way to segregate exceptions is caught exceptions and uncaught exceptions. Caught exceptions, we must handle caught exceptions. Otherwise it will give an error, must be caught or thrown. Caught exception example. Let me see if I can answer you. So I don't need to think too much, right? I can catch it. Index out of bound, IO exception, these are all what? Check exception, huh? IO exception, we can introduce IO exception. How can I introduce IO exception? How do I simulate? All I want is I want to simulate some, when you write that program right here, it will throw without doing that. I don't have some classes handy. File, right? I think when you go to file, when we discussed about files, right, we can understand. Yeah, I'll show you when we try about files concept. Then you will see like a see. Let me see. I'll try. Yeah. I'll quickly try. File equal to, we haven't discussed, just I want to simulate that error. Okay, here if I try to create a file dot, create a new file, see this is valid, but it is saying what? Unhandled exception of type IO exception. Okay, you must either you throw or surround with try catch block. I'll just click surround with try catch block. So when you are writing certain statements, right, these kind of statements, Java easily understands, it catches that exception and says you must throw or catch. Okay, these are called caught exceptions. IO exception is one of the caught exception. Okay, so please finish that assignment. What is that assignment? User defined exceptions. Enhance as much as you can. Not only you need to take a card, right, you can take something else, whatever you think in real time. Okay, try to finish that, because